It's a classic Hollywood action movie scenario. A gigantic asteroid is hurtling towards Earth at breakneck speed, threatening to unleash an unholy catastrophe on our blue home planet. While the protagonists in the corresponding movies always manage to deflect the galactic projectile at the last second, today we would like to deal with the question of what would really happen if an asteroid hit the Earth. Could the planet survive such a collision? What would be the consequences of such an event? And how would things look if the asteroid hit our planet at the speed of light? Keep watching till the end to find out. It seems as if contact between the Earth and other bodies that speed through our vast universe would represent an exceedingly rare event. But, in fact, it's the exact opposite. More than 4 billion meteoroids reach the gravitational area of planet Earth every day. This collective term of meteoroids summarizes small space bodies that are larger than interplanetary dust, but smaller than asteroids. When a space body such as this enters our atmosphere and evaporates, it's called a meteor. So these formations burning up at the firmament appear to us, for example, in the form of shooting stars. However, if a meteoroid succeeds in passing the natural protective cover of our earthly home and strikes the planet's surface, it receives the designation meteorite. And in fact, incidents of this kind are recorded much more often than you probably would have guessed. On average, about 20,000 meteorites fall to Earth each year. However, these galactic projectiles are usually so small that they do not leave any significant damage on the Earth's surface. That's why reconstructing the larger meteorite impacts of our planet turns out to be an extremely challenging endeavor. While we can still detect comparable collision sites on other celestial bodies many millions of years later, the Earth's surface, simply put, has a kind of self-healing mechanism. By this we mean the erosion effects of water and wind, which provide for the fact that the collision places on the planet's surface are eroded within geologically short periods of time. According to this, galactic collisions that happened in the past on the Earth can often be proved only indirectly. The long-term consequences of a meteorite impact can include global climate changes or a sudden mass extinction. So, what would happen if a meteorite hits the Earth? Just going by the enormous consequences that a devastating meteorite impact would have on the climate and living beings on our Earth, lets us guess at the massive elemental forces accompanying such an event. If a celestial body with a diameter of about 1,200 feet fell into the sea, it would cause enormous tsunamis there. The consequences would be even more drastic. However, if the galactic projectile were to strike the Earth's surface directly, a special danger would be the atmospheric pressure waves caused by such a meteorite impact. These pressure waves would propagate at supersonic speeds and ultimately create extreme storms. Experts agree that more than 60% of all expected fatalities would be caused by windstorms. The pressure waves would whip across the Earth's surface with such force that they would uproot entire forests, hurl people through the air, and cause countless buildings to collapse like houses of cards. As a result of this catastrophic scenario, the evacuation of entire regions would be inevitable. However, if the space body hurtling towards our planet is comparatively small, the population could also seek refuge in cellars or shelters. A few years ago, the inhabitants of the Russian city of Chelyabinsk, with its millions of inhabitants, had to experience firsthand the brute force of nature that such an event can bring. In 2013, a 60-foot meteorite exploded in the sky, and as a result of the massive shock wave, around 7,000 houses were damaged, and at the same time, 1,500 people suffered injuries. If the solid body in question has an intrinsic diameter of more than half a mile, the consequences of the collision would be felt over a much longer period. In such a scenario, where such a large asteroid hits the mainland, gigantic masses of dust and rock would be whirled up during the impact. The force of the impact would be so great that some of these particles and chunks would even reach outer space. As the kicked-up debris fell back onto the planet's surface, they would have to pass through the Earth's atmosphere, while the rocks would heat up immensely and ultimately trigger devastating fires on the ground. The smaller dust particles, however, would initially remain in the planet's atmosphere, where they would spread around the entire Earth over time. This process would in turn have a direct impact on the terrestrial climate. The massive dust cover in the atmosphere would make the days darker and colder. If this climactic change were to be maintained over a long period of time, countless plants would die, which would also result in serious hunger crises for animals and humans. Not only that, but the air would be interspersed with dangerous microscopic dust particles and health-damaging toxins as a result of the galactic impact. It is well known that the corresponding solid bodies travel through the vastness of space at incredible speeds. On average, meteoroids can reach a maximum relative speed of an impressive 160,000 miles per hour. This corresponds to over 40 miles per second. By comparison, a standard rifle bullet travels an average of just 3,000 feet per second. However, the entry into the Earth's atmosphere and the associated heating of the meteoroids slows down the galactic speed of the space bodies relatively strongly, while the immense speeds with which meteoroids and asteroids travel already astonishes us. We would now like to push this thought experiment to the extreme and ask ourselves the following question. What would happen if a cosmic projectile hit the Earth at the speed of light? According to Albert Einstein's world-famous theory of relativity, there is a fixed speed limit in the universe that cannot be exceeded, the speed of light. This unit of measurement describes the speed at which light rays travel in a vacuum. The speed of light amounts to an incredible 180,000 miles per second. Before we dedicate ourselves to our actual thought experiment, we do not want to leave a fundamental fact unmentioned. Only massless particles and electromagnetic radiation can travel at the speed of light. This is due to the fact that the mass of an object is also always directly related to the speed with which it travels. Conversely, this means that the intrinsic mass of an object becomes larger and larger the further its intrinsic speed increases. The heavier a structure is, the more energy must be applied to increase its speed even further. The energy demand, which would be necessary to accelerate a solid structure to the speed of light, would finally converge on infinity. However, since an infinite amount of energy cannot be applied in actual fact, it is impossible to move a physical entity at the speed of light. Therefore, we assume here the case that the corresponding flying object would hit the Earth with a speed corresponding to 99.9% of the speed of light. The intrinsic diameter of the meteorite would be about 100 feet. In fact, the impact would be so fast that the projectile would have eaten into the Earth's crust before anyone would have noticed its existence. A cloud of expanding plasma would now rise from the impact site. The energy released during the impact would pulse through the entire planet within the blink of an eye, and thus seal the end of our earthly home. Just 40 milliseconds after the meteorite hit the Earth's interior would be turned upside down in the form of a hot, glowing cloud. The debris that the collision would unleash would be hurled in all directions. Our once blue home planet would now be a scorching hot, glowing celestial body. The luminosity that occurred as a result of the overheating would be even larger than the radiant power of our sun. The escaping energy would be in detail 10,000 times larger than the self-gravitational energy of the planet. Since the Earth simply could not withstand these immense forces, it would detonate ultimately in the context of a gigantic, expanding plasma cloud. However, such an event would not only mean the end of our earthly home, but it would also have devastating consequences for the surrounding representatives of our planetary system. The debris that would shoot through space in the course of the explosion would envelop the sun in a kind of galactic dust mantle. The expanding plasma cloud, meanwhile, would sweep across the surface of the remaining planets and moons, dramatically altering the landscape of the corresponding celestial bodies. Fortunately, such a scenario is a purely fictional thought experiment, but it's known that our Earth was already hit by a huge celestial body in the past, which changed terrestrial life for all time. But how likely is it that an asteroid the size of the object that ended the era of the dinosaurs some 65 million years ago will hit our home planet again? Statistically, such a devastating event occurs about every 100 million years. Nevertheless, experts are already working at full speed to carry out test runs for real asteroid defense in order to be prepared for an emergency.